And so like here's what, kind of looking at cyber vision. This is and this is from the cyber vision white paper that's on that previous link, where that becomes the visibility piece, which then that visibility piece funnels down into all the different enforcement points in your network. Or, to traditional firewall that's doing, perimeter or edge filtering, or if you're doing ICE and access control, and then making those other solutions smarter. And so your policy is kind of more accurate, and bringing in kind of the whole automation of DNA center, right? And SD access, because a lot of these IoT devices are connecting at the access layer, either at a remote site or some type of branch site. DNA center plays a huge part in the automation story of that policy.
Okay.
So it's very much an ecosystem of solutions, and not pictured here is the non-Cisco stuff of these asset data then being filtered up into ServiceNow, right? Or if they, a lot of environments are heterogeneous, right? Being CCIEs, as much as we've done with Cisco, we've all come across where, a customer has Cisco infrastructure and Palo Alto firewalls or Fortinet firewalls, some other types of enforcement, or it could be Aruba ClearPass as their NAC solution, right? So, but that's the thing, and all those solutions kind of operate. The goal of them is to passively look at the behavior. And there's a bunch of different data collection points that they use to pass into the AI and machine learning to identify that asset. When this industry kind of first started, it was all based upon span and tap, which is very difficult to get in certain situations. And also too, you've got, depending upon the model of the switch, you've got very limited span capabilities. You may only have 2 sessions, right, that you can do to set up to mirror traffic, and you already are mirroring to an IDS IPS solution that was put in place years ago. So, span and tap is kind of gives you the best, highest fidelity of information because you're seeing everything. But there's also things like NetFlow, right? Or you can do a simple AD query. You'd be surprised at what you could pull out from just the way a device asks for an IP address. So a lot of these solutions use protocol decoding of like DHCP requests to be able to say, oh, that's option 150 and requesting to download a TFTP file. That's a phone, right? Or it's an access point because of the DHCP option that it's requesting. So there's a whole bunch of different ways that you can kind of skin the cat and mix and match where you pull in. And this is kind of like the octopus slide, where the more tentacles that these solutions are allowed to get into the business infrastructure, the smarter they become, and hence the smarter the AI and learning becomes. I know that's a iPad because I'm seeing, or that's a doctor's iPad because I'm seeing it access PHI data on DICOM or HL7, right? Those specific medical protocols.
Yeah.
I'm looking at, there's things like firewall logs, right? Or vulnerability assessments, like Tenable, Rapid7, a lot of the tools that already exist in an environment these are kind of the legacy active scanners to see where organizations are vulnerable. But the problem is, because I've seen IoT devices that even in 2020 are running Windows Vista, right? The Windows Vista and all those older operating systems and stuff, they exist in environments. And so they're stuck with those assets, because a lot of these are, especially in healthcare, these are multi-million-dollar MRI machines and stuff that isn't on a normal 3 to 5 year refresh cycle. Right.
So I believe sometimes these devices are certified in a way, and if you change or upgrade the operating system, the certification is gone.
Totally, right? And a lot of security isn't top of mind, but then also too, just like organizations go through consolidation, you've got device manufacturers that go out of business, and so there's really no support on it, and nobody developing new patches and stuff for that. Or in the case of like Vista, Microsoft isn't developing new patches for that, right? They're still going back when something big for Windows 7 comes up, but anything beyond that, their stance is upgrade, right? So, but the point of this is these solutions are doable because they're so flexible and they're passive in nature. They're made to not, actively probe these devices and take them down. I've seen, sensors our alarm panels get rebooted because you run a vulnerability assessment against it. They don't like being port scanned. They freak out and reboot.
Well, a lot of those devices tend to be things where security is an afterthought. They're trying to get a device, especially if you're dealing with devices on the lower end of the market, they're trying to get them to market first. And then once they've got that, like, oh yeah, I guess we should think about some security.
Absolutely, right? Security afterthought. And also too, a lot of these devices, that could be home, they're home built, not just the manufacturers, but somebody that works, an employee within an organization uses a Raspberry Pi to do something, right? And deploy that's a solution that is internally developed by, somebody that may not be on the security team and pushed out there, right? And then because those devices, nobody's logging into them daily or looking at a monitor, watching them, right? A lot of those are pushing telemetry data to a centralized system, which is being monitored. Nobody really is watching these, so they don't see when all of a sudden a camera starts talking to Russia, right? And that's a different type of behavior that is an indicator of something being compromised somewhere, right? There's plenty of cases of things like that have happened where devices start doing, they're hacked and nobody knows about it for 6 months, right? Because nobody's logging in and looking at it.
I think, well, with IoT being, maturing the way it is, right? I think that we're in a transition period of security, right? So we went from a model where everybody trusted the infrastructure to handle security, where now it's such a distributed approach. If you're going to put a device on the network, you're really going to have to, understand if it's up to spec, what it's running, if the vendor, if you will, is even keeping up with security. So it's a different. We're in a transition period, and I think that as we go further along down this track, just how we talk about IoT and security is going to change, right? It's going to actually be part of the conversation.
Absolutely, right. And the legacy ways of handling it and things, because this is a daily type of thing you have to stay on top of. This is where the AI comes in and doing AI-driven policy and enforcement of things where when a medical device connects in, it gets this ACL that's for this, in this case, it's a Baxter infusion pump, right? Or here it's a retail system. Somebody connects a credit card machine that's processing credit card data or a point of sale system that gets, I don't care where it plugs in, but when it gets connected, it gets properly identified and then put in the right VLAN, right? Which in the case, here's a VLAN that's for my PCI. Or here's this physical security camera that was put up where once it's connected, it gets the security camera VLAN, right? Or ACL. And then you go beyond that, like, oh, I'm sorry.
Oh, I was just going to say one of the other things, it's not quite shadow IT, but it's another one of those concerns where frequently, IT/network isn't involved until someone says, hey, I bought these, Acme security cameras, and you look at them and go, oh my goodness, these things are an insecure mess. It's like, well, that's too bad. We already bought them, so we're going to use them, and you have to put them on the network.
Yeah. Well, and also too, a lot of these IoT devices are rebranded. So, looking at cameras, if you ever want to reach like the Hikvision cameras, there's a serious vulnerability in Hikvision to be where there is embedded in the chip. There's basically a backdoor in where you can use, even if the admin password's changed, it always defaults back. And that was, is a Chinese manufacturer. Well, that has been rebranded into a bunch of different cameras and resold. And so, a lot of the I think it was last year, the U.S. government said, pull all these cameras, no matter what they are, they're out of our system, right? Because that's a vulnerability that's embedded in the hardware, right? And can't be fixed. So that's why, and it's difficult to track, right? Because if it was in your mind, I don't know if any of the I can't remember if access cameras fall into that category of being rebranded Hikvision, but let's say they do, you may not know that. You may see the vulnerability announcement on a Hikvision. Well, you're like, well, I have access. Really, it's you have Hikvision, you're vulnerable, right? So
I hate to tell you, that problem is so bigger than what you just explained, right? Because in order to have a vulnerability published, you got to be on the radar. There's so many devices that aren't even on the radar out there, and that's why I mentioned at the beginning of this. We were talking about enterprise, but even the IoT devices that are in your home, there's so many things that your microwave, that you can attach to Wi-Fi and things of that nature, but have zero security. You can go in with a password that's published, on Google, so it's much bigger than what you said. In order to be on that vulnerability radar, you got to be important, and there's a lot of devices that don't qualify. So
absolutely, and because they rely on the user when they set them up to change the password, right? Well, I mean, even in our house, we don't always do proper device hygiene and change it. It's admin, right?
Don't say it too loud. Somebody's going to be taking your Wi-Fi later on.
So, I mean, moving beyond kind of the last slide was focused on VLANs and kind of traditional access lists. Where things like NAC and firewall vendors and everything's going is this tagging. Just like within the data center and application, we're starting to tag traffic. Well, now these device and classification, and what you're seeing here is an example of like SGTs and ICE, right? Where devices get the right tag, and then we have, once we know the tag is, there's a trust set policy that gets created that all of the different points on the network are TrustSec aware and know, all right, this is a camera, and I read that camera tag and I process it and send it on its way, right? The network is aware of these tags, and this goes into, Palo firewalls are now using tags, checkpoint firewalls. It's not just TrustSec kind of started with Cisco, but there's more and more that are adopting that layer of communication from a policy perspective, beyond just the traditional kind of access list and VLAN.
Good stuff.
So, and here's an example of a lot of these are doing, protocol decoding. Most of the IoT devices, there's been studies that show about 70% of IoT devices are communicating across clear text, right? So simple protocol decoding, you can pull a lot of information. And so this is a screenshot of a patient monitor that is where they're pulling out things like serial numbers and what the device is, who the manufacturer is, and software versions and things like that by simple protocol decoding, which then those attributes and information can then be presented over, in this case, ICE, so that you can write policy based upon this kinds of other attributes. But that's another thing, is that, a lot of it's out there, right? And so simple protocol decoding, because they're not doing secure communication all the time, you'd be amazed at what any information you can get.
I would think in a hospital environment, though, you probably need to, at bare minimum, have some kind of algorithm. There's some hashing algorithm or something, maybe SHA, MD5, something. But you're saying that is that enforced? Is any of that enforced on?
A lot of these devices, they're not doing that, right? They're just sending it out as a part of their communication, and so that's why it's important to make sure that the segmentation happens, so that if somebody's on guest, they can't just sniff the guest and figure out medical devices, right? Because they're all in the same VLAN. It's a flat network. Right. You want to make sure your network's properly segmented, so these they're not susceptible to man-in-the-middle attacks because somebody figured out the MAC address of this device and what it is, right? And because it was sending things over in clear text.
Well, if these things are wireless, even if they're on an encrypted SSID, if somebody passively captures those, the compute power now is so easy, you could take the time to crunch it later, and then now after you've decrypted the wireless, you have all this, telemetry data, and I've got, Acme Biomed scanner running this software rev. I know it's vulnerable to this.
Right. And so that becomes a form of, kind of social engineering that hackers can use. Of like, okay, I know that's out there. Just like, phishing scams, right? Send, hey, I know this user is going to click on this and tell me your, your social security number. They know Derek's going to click on this, right? If he sees
I always do.
on Facebook, right? The same kind of thing. It's used by that kind of information's out there, and particularly on wireless environments, which there's a lot more wireless devices now than there was 5 years ago, right? And so they will be. It's important to segment, right? And then also too, that's where the behavior comes. So if even if there's a man in the middle attack, and now, all right, hey, this camera, this MAC address and IP that was this camera, well, why is it accessing our finance system or our ERP system, right? That's where behavior becomes critical and foundational to being able to protect, is by monitoring that, knowing that that device is no longer acting like a camera, right? So, and that's where it comes into, mitigating these. And if it is start doing different, this is another screenshot of where this yellow is a behavioral anomaly, right? And so once we see that different type of behavior, that camera doing something different, it gets thrown in the quarantine policy or in a separate VLAN to then go try to, to mitigate, right? If you can even mitigate it. But and then the whole point of getting to the policy enforcement is where we're taking that behavior and what should be normal flows, translating that to policy, and then of what should be allowed, what should be disallowed, what's blocked, what's in, out, those kinds of things, and then pushing that policy to some type of enforcement, whether it's access lists on a switch or VLANs or a NAC solution, or taking it to the point of SGTs and SGACLs. And ultimately, as y'all kind of interact with customers and stuff, some the business outcomes for doing this that we've kind of been talking about all along is to make better, because they know what devices are out there and what assets they have. Businesses can make better CapEx and OpEx decisions about what they need to buy. I've seen customers where the clinical biomed team has been, told, I've got to go buy 50 new infusion pumps because we're running out. We can't find an infusion pump. Well, if they know where they're at, they can maybe move some assets from one hospital to another or one site to another. And then, instead of going out and buying new, they can just reallocate those assets and save CapEx. And also too, from an IT perspective, the automation of the aspects of the policy creation and enforcement, that saves man hours as well as troubleshooting, and lets them focus on like innovation for the business and digital transformation and some of these other projects that they can't you don't have time to develop because you're stuck in the weeds looking at things that are on the wrong VLAN, right? Or troubleshooting tickets.
We probably didn't spend enough time on automation, but a lot of these processes probably could be cleared up with some automation. But going back to looking at your bullet number one, I think a lot of companies have issues. Even I can probably tell you right now that an IoT security line item on someone's CapEx or OpEx plan roadmap doesn't exist. So that's probably the number one issue right now. It's probably be very difficult to get a line item for that. So that's why I say that security is something that is sprinkled out throughout your infrastructure, and it's probably going to be very difficult to even address this spot on. So
and a lot of times to get that budget on the line item, unfortunately, it takes an event, right, of some kind, right? And, either they're fined in the case of like GDPR, they have data loss. And are get a fine, or there's some type of event that happens which changes the behavior, and then once that happens, the pocketbooks open up, right? The most well-funded organization, because we got hacked, at least for the next year until or 2 years, until it gets far enough back in the distant memory that we start kind of chipping away and moving those funds around, right?
Yeah. Mm-hmm.
So
another thing that would add to the amount of data that you have to sift through as you build a profile for something And then suppose they're devices that have auto update and the manufacturer pushes new software and then the software starts acting different.
Right. Oh yeah.
And you would never know.
Yep.
I've seen cases where a lot of cameras use a centralized NTP server, right, to sync your clock. Well, that URL could change, right? Or they go and they don't do time.org, right? They use something else, right? Or an update server, right? And just by that's another example of looking at what a device is looking at for updates. If it's going out to Symantec or McAfee or something, update.com, you can pretty much infer that device has antivirus installed on it, right? Because it's going to McAfee, right? And so that becomes another inflection point of the device and the security of the device, because you know that it's been patched and has antivirus installed. Whereas if a workstation, you never see it, going out to update, that its antivirus isn't installed, and it's because it's not in the right OU and Active Directory, and you're not pushing the applications out. There's a whole bunch of different kind of use cases for these types of systems out there that a lot of customers are looking and implementing.
Unfortunately, it all depends on knowing exactly where they all are located anyway. I mean, most of you guys, most of you guys can probably relate. You guys remember when the SQL server, and this is Microsoft's SQL server years back, had so many vulnerabilities. So you go through the company, your customers will have you, and you say, oh, this is all we know about. Then you run a scan and realize that on the secretary's desk, she has a server running Microsoft SQL server, So these things, it's very easy to say, we can put a plan together. I can tell you most organizations, like for example, an IoT device, a scanner, something simple. Scanners you guys use to scan, phones in or different boxes in, codes in. Those things are an afterthought. You don't even think those things have an operating system. Some of them do. Some of them run on, Microsoft CE, or some of them have Linux, but bottom line, they have operating systems. So any operating system can be exploited. So it makes it seem simple, but trust me, it's not that simple.
It all starts with inventory and then behavior, right?
Yep.
Yep.
Where are we
Right,
at?
guys, I've got to shoot. Yeah, I've got to shoot anyway because I've got stuff to do. But that was really good, Rick.
Thank you so much. But look, before we even leave this section, I want to make sure that everybody listening to this, subscribe to NN6. So subscribe and give us a like. And we want to thank you for even listening to IoT Security. And thank you, Rick, for bringing this information to us.
My pleasure.
Awesome job, Rick. And don't forget to share as well.
Yeah, like, share, subscribe, period.
Okay.